Okay. So, right. The idea here for Cheater's Hangman is there is basically this kind of ability of the computer to cheat by having the entire dictionary at its disposal for this problem. Sorry. Second. I'm looking for my pen. There it is. There we go. Pen. So now, let's see. Share screen. Whiteboard. Okay. So the idea here again, using the example from the assignment, is that if we're playing a game of Hangman, right, the human is always going to be playing as the guesser, right? And the computer is always going to be the person choosing a word. The user does dictate how long the words are, but so let's assume the user wanted 4-letter words. And again, like there were a bunch of words like look, took, look, book, tape, let's go with flee, and let's go with good as well. All right. So suppose that you have, let's see, one second. All right, so suppose you have these words that basically, suppose that these are the only 4-letter words in the English dictionary, okay? Your computer obviously has a bunch more than that, but what the first thing the computer will do before even starting the game and asking for them to choose a word is that they will go through and figure out, hey, how many, let me group all the words together by how long they are. Okay, so first thing it will do is group all the words together by how long it is. It will do this once and only once, because it only needs to do it once. Doesn't need to do it every time you restart the game. Or sorry, every time you ask the user if it wants to play. You just need to do it once at the beginning of when you execute this program. So what we're going to do now is that we would ask the user to give us a guess. Okay. So let's suppose that the user is going to guess the word, the letter E, because E is the most common letter in the English alphabet, right? So here's what we would do. We would guess, the user's going to guess E, okay? But here's what's going to happen. We would then create ourselves what are called word families to try to figure out, okay, if I were to, right? Because the idea here is that the way the computer cheats at Cheater's Hangman is that it doesn't commit to anything. Rather than just choosing a single word, okay, it's going to basically use all the words in the dictionary as its disposal and just pretend that it chose one. Now, the way it needs to get around, now the thing is to be undetected with cheating is that, hi, Laser, is that the computer needs to figure out, basically need to make sure that there's no inconsistencies in between what's going to be revealed and what, in between what they've revealed so far and what word they eventually decide to show the user, or what words they have to choose from. Right? For instance, you can't just say everything is wrong, because if I guess A, E, I, O, U, except for a couple of words that you're gonna have to reveal a letter somewhere or some letters somewhere, because there aren't the number of words without vowels are very rare, and even then they basically have Y in them. So it's got to reveal that at some point. Okay. Now, if I put in, but basically, if I say that, oh, E is wrong, and then I said, but the word I was thinking of was tape, the person's going to think either A, the computer's cheating, or B, the program isn't finished yet. So what we needed, so we got to make sure none of those inconsistencies happen. Now, the way we do this is by splitting a word up into word families. Now, word families require basically just two things. The words that we currently have as possible words to tell the user we were thinking of, or of words that we had that we are thinking of that, and all the letters they've guessed. So here they've guessed E, so we need that and all these words to make our word families. So let's go ahead. So we can take took, look, took, rook, and book. So the process is going to be the same for each of these. We figure out hi Laser. We figure out what word family each belongs to, which is look belongs to the blank, 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 blank family. Why? Well, if we were to commit to look as our word, what would be revealed? Nothing, because we've just guessed an E, so nothing would be revealed. Okay. Here. Look. And so the same would be for took. If we were to be reduced to one word and that word was took, and we were to commit to it, nothing would be revealed based off this guess. Same with rook, book. Tape would belong to a different word family. It would belong to blank, blank, blank E. The position and the number of letters that have been revealed are significant, matter. So it's not just how many E's are revealed, but it's also where they are. So tape would belong to its own word family. Flea would belong to its own word family. Blank, blank, E, E. And then good. And then goad. Okay. And then what we need is also, let's go ahead and just show one more word. Ears. That would be E blank, 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 because, so notice that even though it has one E, it's in a different word family than the other word with one E. Okay, so with this, basically, we have to commit to one of these, because if we say that, because if we reveal an E, we can't use took, look, rook, book, or any of those other ones. They're gone. They're done. If we revealed one of those as our word we were thinking of, they'd go like, but I guessed an E. You told me there was an E in it. No good. So we have to commit to one of these. So my strategy is always choose the one that has, so we got to choose the best word family. And generally the best word family is the one with the most choices for us in it, the most words. So we'll basically eliminate the others and we will say, hey, took, look, book, rook, and good are going to, and goad are going to be, is going to be the new word family. All right. And now let's go ahead and see how that works with a correct guess. Okay. And we don't change what we show to the user because they didn't get anything right. So we decrease one of the correct guesses. So now let's say they guess an O. So now we need to basically split this up. Now, look would belong to the OO blank. So actually I can just do this up here. These all belong to the same word family up here. because you go through them and you're like, huh, we wouldn't reveal the L, so that's a blank. We'd reveal the O, and the O, and for the for this, but we would not reveal the last letter because that is not a guessed letter or a letter that's been guessed. And over here, this would be, because it's goad, it would be one O and a blank and a blank. And then we would choose the biggest word family, which would be this one. So we would eliminate this one. We choose the biggest word family. It has two O's in it, which is different than what's up here. So we replace what's up, but we will always replace what's up here with this key over here. So what is the stage structure I'm using? I'm basically building the list of words is a list. Doesn't matter which type. But the way when I split it up, I'm categorizing, which means I'm creating a hash map where the key is the string, which is the word family. And we throw away all our word families at the end of a turn, and we have to create new ones every time they guess something. But each time it gets reduced shorter and shorter because we're dealing with less words. So we threw away the one with the single one. We tell the user they guess something right and they should guess it. So, okay. Now let's go ahead and give you some starter code for that. Right, because so this one's weird. I suggest like doing a lot of this in main. But I mean, you can also split it up, but you need to also keep some parts out of it. So let's go ahead and create this. So I just installed this on my, so give me a couple of seconds to just set this up so that you can actually read. Theme. Yeah, let's go ahead and sync with the OS. Doesn't really matter. Okay. Appearance, Segue UI. We're going to boost up the UI here. And now let's go to the editor, font. No Cascadia in here, but that's fine. I'll go to Fira code, enable the ligatures, and go to 16, 20 in the size of the font size. And we'll just go ahead. And yeah, I do much prefer working in a light theme. So public class cheaters hangman. Here's what we're gonna, so first let's go through each of the functions I want to make. Public static void sorry, one more time, because I don't think it's big enough. I'd like it to be comfortable and easy to see for everybody. Okay. No, I reformatted my computer. I am on my laptop, but I redid my laptop last week and haven't had to use IntelliJ. Or rather haven't had to do IntelliJ for projection. And I installed the latest build of Windows 11 on it to test it out. I have only one issue that causes a crash, which is very interesting, which is when it goes to sleep and the headphones are plugged in. Okay. So public static. So let's go ahead and create our first method, which is create word lists. And that's going to take in, let me set this up to my, geez, it's not fun to type on this. Oh, wait a second, I have a keyboard for this purpose. Create word lists. String file name, and yes, I have to add in the return type. So this will take in a file name, and it's going to give me back a list of, a map of integer to list of strings. So this should be the first thing that you need to program. And what does it do? Well, what it's going to do here is that it is going to take in the file name, read all the words from our dictionary file, and it's going to give us back a word list over here. Sorry, it's going to give us back a map of word lists. Specifically, the key, so we have a key and a value. So if I ask for instance, for word lists, if I go word, okay, new hash map, new hash map, return word lists. And we'll have to fill in the middle here. Okay, so we'll fill in the middle. And what we're going to do, and what we do over here is basically, the end result is that if you were to give me, if I were to ask for word lists dot get 7, what it will return is it will return a list of all the 7-letter words. So this is the first thing that happens. Basically, you give it the dictionary file name, it reads through everything, and it's going to split all the words up into categories, and they're going to be categorized by how long they are. Hopefully that makes sense. Basically, you ask how long each word. Now, in the file, right, every word is on a line. So you read the line, ask how big is the thing in it, and then you figure out what whether or not the map exists and add it to the appropriate map. Okay. So the next thing we'll want to do is, this is the one where, this is the other one that will be using a map. It's going to be using a different map. It's going to be using a map with a different key and value. It's going to be doing string to list of string. And it is the create word families. So. And that's going to take in a list of string. Word list and a set of characters called guesses or guessed. So this takes in the word list of all the words that we can currently use and all the letters that have so far been guessed. And again, I'm just going to go ahead and initialize the thing that we are going to return. Word families. New hash map. And there we go. So, well, and obviously, yes, the bulk of the code is going to go in between here. But basically what you want to do over here is the process I just went through by hand, which is I look at all the words that have been guessed so far, and figure out what word family you have. We can break that down just because that might be a bit easier. Public static string find word family. Given a string word and a set of called bind. So given a string of words and a set of guessed letters. So basically using what was passed in up here earlier, using what was passed in over here. And return. So string family is equal to return family. And for this one, to figure it out, you're gonna have to go for string for car letter in word.toCharacter array. You want to go through each letter and ask, hey, has it been asked before? Is it something we've asked for before? Make sense? And then finally, what we're going to do is the last one that you'll probably need to make is public static, and this one will turn a string get best word family.
Hi, Daddy.
Hi, Laser. And that is going to take in, it's going to take in this as an argument. Does it need anything else? Nah. And we'll just simply put in a string best family is equal to all right. So again, so this is what I'll give you in just a second, but to review, what do each of these do? So this gets run basically at the very beginning of the program, which is that we do this kind of once, which is that we go through all the words in this file and we categorize them. We split them up into a map based off of how long they are.
A little bit more. Need some energy for the day.
Then we have create word families, which basically gets run every single turn. Okay, and what that does is that says, given the word list and given the guessed letters, then what we want to do is that we want to iterate through every word in the word list. So let's go ahead and be more explicit now. For string word in word list, what we want to do is we want to figure out the family for each of those, for that word. And then based off the family, so once we figure out the family, we want to add it to the appropriate list associated with that family. Okay. And then, so how do we find the word family? What we go through is we go through every letter in this word. And we essentially just keep concatenating to this family variable. If we've seen this letter before, in other words, if the letter has been guessed, then we just concatenate the letter. If it has not been guessed yet, we just concatenate an underscore. Okay. And then finally, we've got get best word family, which occurs, which also gets called every turn after you create all your word families. And the way that is you look through each of the word families and you ask, hey, is this the best one? Is this one the biggest one? And that's pretty much it. So let's go ahead. I'm going to stop sharing.